Article 426 of the National Electrical Code requires ground fault protection of equipment, or GFPE, for de-icing equipment. The theoretical question of whether an arc fault circuit interrupter, or AFCI, could be an acceptable alternative arises, especially considering the cost difference. However, the answer is no. An AFCI breaker would not be an acceptable alternative to a GFPE for de-icing equipment as per Article 426 of the NEC. The reasons are as follows. Firstly, different operating principles. AFCI breakers detect arcing faults, which are typically caused by electrical equipment or wiring issues. GFPEs, on the other hand, detect ground faults, which are caused by current flowing through an unintended path to the ground. Arcing faults involve current jumping across a gap, often generating heat and potentially leading to a fire. Ground faults involve current leaking to ground, which can pose shock hazards to personnel and also cause fires. The way these devices sense these problems is fundamentally different. An AFCI looks for the signatures of an arc fault, which can include erratic current patterns, high-frequency noise on the line, and other indicators. A GFPE measures the current balance between the ungrounded, or hot, conductor and the grounded, or neutral conductor. Under normal conditions, these currents should be equal. If there is a ground fault, some current will return through a different path, such as through a person or conductive material to ground, creating an imbalance that the GFPE detect. Secondly, sensitivity is a factor. AFCI breakers typically trip at around 30 mA of arcing fault. While this is similar to the trip level for GFPEs, it is important to note that arcing faults and ground faults have different characteristics and require different levels of protection. The 30 mA trip level for AFCIs is designed to detect arcing faults before they can escalate into a significant fire hazard. For GFPE devices used in de-icing applications, the trip level is also around 13 mA, but this is specifically to protect equipment from damage due to ground faults, not necessarily to protect personnel from shock. Personnel protection typically requires a much lower trip threshold, such as 5 mA, which is used in ground fault circuit interrupters or GFCIs. The key difference is that AFCIs are looking for the characteristics of an arc, while GFPEs are looking for an imbalance in current. Thirdly, the purpose of each device is different. GFPEs are specifically designed for de-icing equipment to protect against ground faults, which can be dangerous in the presence of water and ice. AFCI breakers are not specifically designed for this purpose and may not provide adequate protection against ground faults in this application. De-icing equipment, such as heating cables embedded in concrete or asphalt, are often exposed to harsh environmental conditions, including moisture and temperature variations. These conditions can increase the risk of ground faults. If a heating cable is damaged or its insulation deteriorates, current can leak to ground through the surrounding concrete or asphalt. A GFPE is designed to detect this leakage and quickly de-energize the circuit, preventing further damage and reducing the risk of fire or shock. AFCI breakers, while effective at detecting arcing faults, are not designed to detect these types of low-level ground faults. The NEC compliance is a fourth consideration. Article 426 of the NEC specifically requires GFPEs for de-icing equipment, indicating that AFCI breakers are not an acceptable alternative. The NEC is a widely adopted standard for electrical installations, and it is based on years of experience and testing. When the NEC specifies a particular type of protection, such as GFPE for de-icing equipment, it is important to follow that requirement. Using an alternative device, such as an AFCI, may not provide the same level of protection and could violate electrical codes, potentially leading to safety issues and legal liabilities. The NEC requirements are very specific and should be adhered to. The code-making panel has determined that GFPE protection is needed for the de-icing application. This requirement is based on the specific hazards associated with these systems. Using AFCI protection would not meet the intent of the NEC. GFPE works by monitoring the current balance between the supply and return conductors. Any imbalance indicates a leakage current to ground. This leakage current, if allowed to persist, can cause overheating, fire, and shock hazards. The GFPE device trips the circuit when the leakage current exceeds a predetermined threshold, typically 30 mA for equipment protection. An AFCI, on the other hand, detects arcing faults, which are characterized by erratic current flow and high-frequency noise. Arcing faults can occur due to damaged insulation, loose connections, or other wiring defect. While AFCIs provide valuable protection against fire hazards, they are not designed to detect the low-level leakage currents associated with ground faults. The NEC mandates GFPE for de-icing equipment because these systems are often installed in wet or damp locations, increasing the risk of ground faults. Additionally, the heating elements in de-icing systems can be subject to mechanical stress and damage, further increasing the likelihood of insulation breakdown and ground faults. Therefore, GFPE is essential to protect both equipment and personnel from the hazards associated with these systems. Substituting an AFCI for a GFPE would not provide the same level of protection and would violate the NEC requirement. The NEC is not just a set of rules, it's a comprehensive safety standard developed by experts to minimize electrical hazards. Following the NEC ensures that electrical installations are safe and reliable. When it comes to de-icing equipment, GFPE is the specified protection method, and there is no acceptable alternative. The code also specifies that the GFPE shall be a Class A device. This means that it must trip at a ground fault current of 6 mA or greater. This level of sensitivity is necessary to protect people from electrical shock. GFPE devices are typically installed in the circuit breaker panel that feeds the de-icing equipment. They work by monitoring the current flowing in the circuit. If the current flowing out of the circuit is not equal to the current flowing back into the circuit, then there is a ground fault. When a ground fault is detected, the GFPE device will trip the circuit breaker, cutting off power to the de-icing equipment. This will prevent the ground fault from causing a fire or electrical shock. GFPE devices are an important safety device for de-icing equipment. They can help to protect people from electrical shock and prevent fires. Article 426.28 in the NEC covers ground fault protection for de-icing and snow melting equipment. Electric de-icing and snow melting equipment shall be provided with ground fault protection for equipment. There are exceptions for fixed outdoor electric de-icing and snow melting equipment other than those employing resistance type heating elements, impedance heating, or skin effect heating. The requirements help minimize the fire hazard due to ground faults. The GFPE protection required is not the same as the GFCI protection that is required for personnel protection in dwelling units and other locations. GFCI protection is intended to protect people from electrical shock, while GFPE protection is intended to protect equipment from damage due to ground faults. There are many types of GFPE devices available, and each has its own advantages and disadvantages. Some GFPE devices are designed to trip at a lower current than others, and some are designed to trip faster than others. It is important to choose a GFPE device that is appropriate for the specific application. The NEC requires the GFPE devices be tested periodically to ensure that they are functioning properly. The testing should be performed by a qualified electrician. During testing, the electrician will simulate a ground fault to ensure that the GFPE device trips the circuit breaker. The testing should be documented, and the documentation should be kept on file. The NEC also requires that GFPE devices be replaced every few years. The replacement interval will vary depending on the type of GFPE device and the environment in which it is installed. It is important to follow the manufacturer's instructions for replacement. The NEC is constantly being updated to reflect new technologies and safety practices. It is important to stay up to date on the latest requirements. The NEC is available from the National Fire Protection Association (NFPA). While the theoretical discussion may raise questions about the potential suitability of AFCI breakers for this application, it is important to adhere to the NEC requirement for GFPEs. This ensures the proper level of protection and compliance with electrical safety standards. Therefore, when installing or maintaining de-icing equipment, always use GFPE as required by the NEC and consult with a qualified electrician to ensure proper installation and operation.